Last week, when we were dealing with proportions, we did some practice in finding what our sample size should be for a given margin of error. So if you'll recall last week, we did some calculations with the margin of error, and previously we used the formula, the margin of error equals z star, and then we did p hat q hat over n. And that was all well and good because we knew that z star was the same no matter what the sample size was. If it were, say, a 90% confidence, we always use 1.645. And if it were 95% confidence, we always used 1.96. Now what we're going to do is we're going to do the same, but we're going to be dealing with those t values. But the problem is these values aren't as easy to come up with because remember our t star, our critical value, has everything to do with sample size. So what we're going to do is we're going to look at an example with our battery lifespan. And we had found the 306.25 was our mean and our standard deviation was 29.31. And we want to know what the margin of error, or essentially what the t-star would have to be within 15 minutes, what the sample size would have to be within 15 minutes of the actual population mean. So this means plus or minus 15. This is our margin of error. So we're going to do this calculation. But the problem is we don't know n, that's what we're trying to find. So it's a little bit trickier because what I have to do this week is I have to first use z star. Now remember z star for 95% was 1.96. That's where I got this value. This is my margin of error from the previous page, and this is my standard deviation. So what I would like to do now is I need to find sort of a starting off point for what I'm looking for, which means I'm going to have to solve for n based on the normal model and then use that number to solve for n based on the t model. So it's actually doing the same calculations twice to make sure we're as exact as we can be. So for the first, I've got my 15, my 1.96. Of course, I'm going to divide each side by this first. These calculations are a little bit different than last week because last week we had the square root over the whole thing. Now I'm going to take this side times radical n, and then I'm going to divide this side by 15 over 1.96, which means, of course, that I'm multiplying by the reciprocal. So you can write it like this, or you could have had the 29.31 multiplied by the reciprocal, which was 1.96 over 15. Either way, notice what I'm ending up with is I have about 15 because I'm rounding up. Now 15 is not my solution. My solution is now I have to do the exact same using a test statistic for 15, which means 14 degrees of freedom. So again, I used my calculator or StatCrunch to come up with that 2.145. I'm doing all of those same calculations again, and I find that n is 18. So I'm rounding up to that 18, and that's the value that I would use. Here's a similar question for you to try. So press pause, try this question, then press play to check your work. So what I have here is I have jelly jars, and I'm going to measure the actual weight of the product in the container. We need to collect enough data, which means finding the sample size, to construct a confidence interval with a margin of error of no more than 1 gram. So less than or equal to 1 gram is our margin of error, with a 99% confidence, and then they tell me the standard deviation. So again, I'm using my margin of error of 1. Notice here I've got 2.576, which is my z star for a 99% confidence. I'm solving to find about 27, and then I'm going to plug the 27. I'm going to say that my degrees of freedom are now 27 minus 1, which is 26. And that's how I found this test statistic using my t star. And then I solved again, and I said 31. So I need it to be basically less than or equal to 30.89. So essentially, I would actually say 30, because 30 is less than or equal to 30.89. So typically we would round up, but because this one is actually sort of a less than question, I would choose that 30.